Welcome to Rges Algebra 2. This is lesson 3.4, having to do with equations of linear functions from their graphs. We've been working on this quite a bit here already. We've talked about the three kinds of linear equation forms, general formats. Okay. The first one would be the slope-intercept method, plus b, mx plus b. The second one would be the point slope method, y minus y1, where the second one is an actual value, equals m times x minus x1. And the third one is a form called ax plus by equals c, where both the x and the y values are on the left side of the equal sign. Now, if you are given a slope of minus 3/2 and that the line contains the point 7 minus 5, can you write an equation for the line? Well, which would be the most natural form to use? And that would be this one here, certainly. And you would write it. Now recall that this has a minus sign both places, so where I've got my y value, I want the opposite sign, and then plug in my slope, and where I have my x value, I want the opposite sign. So if it's 7, you want a minus 7 here. And that is because the general equation has a negative sign in both those places. And then, let's see, it says find the particular equation of the linear function. And so that's all you have to do is pick the most appropriate form and plug it in. For example 2, it says find the particular equation of the linear function containing the points. Now this is an interesting one. So this was example 1. Example 2 gives me the 2 points, minus 4, 5, and 6, 10. Now I don't have a particular form up here in my three general equations that I could plug in just 2 points for x and y. Okay. Number 2 does not allow you to plug in both. Okay, you need that. The first one has to stay the variable. Okay. So what could I do? Well, if I use both these points, I could solve for m, and then I could choose either point to plug in for the point in the slope point formula. Okay. In other words, how would I solve for m? That's the change in the y over the change in the x. The rise over the run. The rise would be the y value. Okay, so if I say, I could start with either point, but if I say 5 minus 10, that would be negative 5. For the x, I've got negative 4 minus 6. That would be negative 4 minus 6 would be negative 10. And so my slope would be 1/2. And now I could plug in, choosing either point from above. It doesn't really matter. I'll choose this one. Y minus 5 equals 1/2 x minus a negative or plus 4. Now, when you go to the book, he'll plug it in either way. He'll plug it in that way, and then he'll plug it in this way. B minus 10 equals 1/2 x minus 6, and we can prove that both those equations are of equal value. And he does that on page 87. So I'm not going to do that. He puts them in the general form so that the x and the y are both on the same side of the equation, and then converts it to whole numbers, and you'll see that they both are the same. The next idea he talks about is parallel lines. Let's say I have my x and my y, and I have one line and another line that's parallel to it, and what can I say about line 1 and line 2 regarding their tilt? And the answer would be is that their tilt, which is again another word for their slope, is the same. So the slope of line 1 equals the slope of line 2 when line 1 and line 2 are parallel. Okay. Now perpendicular lines. Okay, so if we have, let me just say it this way, parallel lines, same slope. Now if I have perpendicular lines, that would be a line there, and then the other line, such that this forms a right angle. What can I say about their slopes? So perpendicular lines, the slopes are the negative reciprocal. So if the slope of line 1, let's say, is 3/2, then the slope of line 2 would be negative 2/3. So example 3 says, find the particular equation of the linear function containing the point -2,7 if its graph is perpendicular to the graph of 3x plus 4y equals 7. Well, I have a point, and so what I need is a slope, right, to use the point slope method. So I know that the line is going to be perpendicular to this line, so if I can find the slope of this line, then I could take the negative reciprocal, and that would be the slope of this line up here that I'm talking about, my new line. So how would I do that? Well, to find the slope, the easiest way would be to put it in the slope intercept form. And so I'm going to solve for y. Dividing. And my slope for this line, the perpendicular line, is -3/4. So the slope for the line I want to find the equation for is going to be positive 4/3. Now it becomes very easy to find the equation. I simply say y we're going to use the point slope method, so we're going to say y minus 7 equals 4/3 x plus 2. What about the slope of a... Now, how would we find the equation of a line that's a horizontal line? Okay, well, we don't know. Notice the x value can be here, 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 but the y value stays the same. So if the x is here, the point is there, If the x is there, the point's there, and the y value is not changing. So we simply pick up that y value, in this case 1, 2, 3, and y equals 3 is all we have to write for a horizontal line. Again, if we had a vertical line, and let's say it's the x value that's never changing, so we write x equals -2. And that's all there is to that. If I gave you a point, if I said there's find the particular equation of a horizontal line through 7, 8. Okay, a horizontal line has to do with the y value, so you have to think that through. It's where it crosses the y-axis. So I'm picking up just the y value of the point. Y equals 8. If I ask, find the particular equation of the vertical line through 7, 8, I'm thinking of a vertical line. A vertical line passes just the x-axis, so pick up the x value, and x equals 7. And that's really very straightforward, I think, to think about it that way. Now, if we're looking at the quick exercises on 3.4, page 90, there's a few of these only that I want to go over. It says find the X intercept. I haven't really talked about that with an equation. To find the X intercept, remember where it crosses the x-axis, okay, what is the value of, let's see, here's my y, here's my x, here's a line that I want to know where it crosses the x-axis. Okay, where it crosses the x-axis, where's the value of the y? Or what is the value of the y? To cross the x-axis, the value of the y has to be 0. So plug in a 0 there, you get 3x equals 36, or x equals 12. On the same token, if I asked you, what's the y-intercept, I would plug in, so my point, by the way, would be 0, 12, 0, right? 0 for the y and 12 for the x. If I ask, that's the x-intercept. If I ask for the y-intercept, I'm asking where's it cross the y-axis? Okay. The x value is 0, so you plug in 0 here, and 4y equals 36. And so y equals 9. So that's how you find the x and the y intercepts. Number 30 says 30 is 40% of what number? Now we saw one kind of similar to that last time. We would say 30 is, in relationship to the larger part, the same as 40 over 100. So we would set up a proportion that way, cross multiply, we get 3,000 divided by 4, and you can simplify that. 7, find the slope. Y equals 4/7 plus 3x. Well, that's a little out of its proper form because normally these two are reversed, but the slope is always the one that goes with the x, the constant associated with the x. So the slope is 3. To divide 2/3 by 3/4, number 9, just recall that division is multiplying by the reciprocal. And to square a binomial like that, just think in terms of FOIL, write it out. If you don't know the pattern automatically, x minus 3 squared, just write x minus 3 times x minus 3 and square it out. Okay, I think we've covered all the ideas in that chapter. I'll go ahead and do the work, and if you have any more questions, bring them to class.